So show all work, include your units. That's kind of the theme of this semester. Label each calculation. So this is like the second part of your lab write-ups that will be due next Thursday. The first part, and let me know if you have any questions, but the first part is your summary, and it actually has, the first part has 3 parts. Remember I talked about the purpose, your experimental, what you did, and your results and discussion. That will be typed. This will be your second part. I would write this in pen. Okay, I would just take a clean white sheet of paper, or even a sheet of paper with lines if you prefer. Only write on one side of the paper, but I would do my calculations in pen. Some students are like, hey, I got that whole word processor thing down with superscripts and subscripts. I'd be like, oh, okay. Okay, so label it. So for instance, I said, I even gave you one label that you need to label all these calculations, but appropriate label would be volume of block. Okay, block. Now if I don't see volume of block, then you're going to lose a point. Okay, 1 out of 10. You don't want that. Okay, so the second one is to go ahead and get the density of the block. So density is a ratio of mass to volume. So in your recording, you have the mass, and now you have the volume from calculation 1. Now, what will the units of density be for this one? What will the units of volume be for your block?
Grams.
Centimeters cubed. Yep. The volume of your block will be centimeters cubed. So what will your density be? Grams per centimeter cubed. Exactly. Yep. And the dimensions are going to kind of work out when you work it. Will fall into place when you work it. So.
So we don't write our calculations in our notebook?
That's a good point. It's optional. I've seen students do it both ways. You don't have to write your calculations in your notebook. If you write them in your notebook, you need to rewrite them on another piece of paper. So
we would do this format on one page, and then the next page we could just do calculations.
yes, you could in your lab. An advantage to doing it in your lab notebook, especially if you decide, like, lab partners want to get together and knock out the calculations. Sometimes they just do it right. I would do it right after lab. You know, usually these labs take an hour and a half-ish. So, but any questions? If you do your calculations in your lab notebook, which I think is kind of cool, right after your data, then do your calculations, then you still need to write them on another piece of paper for your semi-formal lab report.
Okay. You're recording the data in your lab?
Yep, you're recording, yes. Okay. You're recording data there and calculations there if you want. Okay? The first one's always the hardest. Okay. So the calculation 3 then is what's the density of the stopper. So of course you have the mass of the stopper in grams, and you should have the volume of the stopper in milliliters. That was the displacement one. So the units of density there will be grams per milliliter. Then on to part 2 with the cylinder. The volume of the cylinder, and sometimes students might wonder, now, am I going to have to pull that out for a unit exam or something like that? No. If you need it, I'll give it to you. But the volume can be calculated as pi, the radius squared, times the height. Just remember that when you got that chord, you got the diameter, not the radius. So, of course, the radius is half of that. Okay, so plug it in. And units of volume here will be cubic centimeters. Now, this one, B, 4B, we're going to get to that in lecture. We haven't done that yet. So, some of you may know that if you have the mass, where'd my cylinder go? Okay. If you have the mass of this water, and you have the volume of, if you have the mass and the density, you can calculate the volume. So this one says that you're supposed to go to a page around in your lab write-up, and you're supposed to come up with the corresponding density of water. And so I just kind of picked 22 degrees Celsius. So if you go to page 2.7, you look at 22 degrees Celsius, and you see a density of not 1.00, but you see a density of 0.99780. So here's how you would do this calculation. Again, we're going to talk more about this. So you see this on the table? Okay. So here's how you use density and mass to get to volume. In this case, I said the mass, I just kind of picked a mass, was 15.372 grams. That's the mass of this. In this case, I said the density at 22 degrees Celsius was this. To work this, and again, we'll talk more about it in lecture, but to work this, we're going to actually, our first term is going to be mass. The second term, you might recognize, is the flipped version or the inverse of the density. The reason we do this is so that our units of grams will cancel. Units of grams from the mass cancel with units of grams from the density, and we have units of milliliters on the top. And we talk more about this. I'm just kind of laying it out. Better talk about it before Thursday, shouldn't we? So if you let your units do the driving, we know that this is where we need to be. So your calculator will say, well, hopefully it won't say anything. That will really kind of be creepy. But it will display a number 15.4089296. Of course, units are milliliters because that's what units we were left with. And we've been talking, how do we need to round this? Sig figs or decimals?
Sig figs.
Sig figs, and how many sig figs?
5.
5. I'm liking 5 either way, but I kind of picked on the first term. So if we pick 5, I kind of showed it truncated. Since the 9 is greater than 5, we're going to go ahead and round that 8 up to a 9.
So for this lab, are we using the 22 degrees Celsius number?
So for this lab, I'm just going to I'll write it on the board what the temperature is. Yeah, I'll kind of try to see if I can hone that in. Very good. Okay, so on to part 3. Dun, dun, dun. Oh, by the way, let me go back. Can I go back? So one of the things, I'll maybe add it here. Do you guys see where we have basically come up with volume of the cylinder 2 ways? I'm just saying, it would be nice then in that first part in your summary, to me, I would include in my summary, my results and discussion, I would say, I got the volume of the cylinder using actually a third way. Because remember how else we got the volume of the cylinder? We just filled it up and dumped it into the grad cylinder. The volume of this cylinder, remember this? Yeah. So my point is actually, you got it 3 ways. I would compare those 3 ways in my summary. I'll say summary, it's up to you, but you got to put something in there. And a lot of times, what are you going to put in your summary? Well, look to see what you calculated. Okay, so let me know if you have any questions about that. Okay, on to part 3. So in part 3, that's where you guys had the pipettes, aliquots transferred, and you got the mass. So you should have each done that 3 times, and you guys are going to share data. So that's a total of at least 6. So calculate the density for each trial. So I have M1, meaning the mass of the first aliquot, M2, the mass of the second aliquot, etc. Density is mass divided by volume. In each case, your volume was a sweet 10.00 milliliters. Okay, so you'll have at least 6 of those. That's calculation 5. Calculation 6 is just a simple average. So calculation 6, we're going to add them up, and if there were 6, we're going to divide by 6.
So for this part, we average ours in with our partners.
Yes. Okay. Yep, you got it. You got it. Calculation 7, it feels a little weird to me because we're actually trying to get a really close density of water based upon the temperature of the room. But here I'm like, all right, assume that the density of the water, the true value, aside from what the current temperature is, assume a true value is 0.998 grams per milliliter. All right, we can do that. And then we're going to use that value in calculation 7 to come up with a percent relative error. We kind of talked about this in class a little bit. So percent relative error is going to be always, it's always experimental minus actual. Sometimes actual is theoretical. In this case, actual is the true. So experimental minus actual divided by actual, okay, and times 100%. Any questions about that? So your 0.998 grams per mil will appear here and here. Your experimental will be the average of your 6 trials. In this case, I don't know if you guys see this, but can you see units actually all cancel out? So percent relative error actually is what we say unitless. Okay. So I gave the last calculation its own page because sometimes I'm not a math teacher and I have a hard time explaining this. So you guys are going to calculate an average deviation. And if you think of what average, the word average deviation, it kind of is what it is. So first you calculate the individual deviations. Okay. Notice the row bar with a bar over it, that's average. That's your calculation 6. So basically for each of your trials, you're going to come up with a difference. Trial 1 minus the average. Trial 2 minus the average. Trial 3 minus the average. All the way down to 6. I'll tell on myself, I forgot when I did this until the end, what did those 2 bars mean? Absolute value of, yep. Sometimes when I'm explaining this, I totally forget that. So you want the absolute value of those differences. So that means if it's negative, you're going to make it positive, right? If it's positive, you're going to leave it alone. Okay, so it's the absolute value of those differences. That's the deviation part. And then the average part comes in here. So it's really not that complicated. The average part comes in where you basically take those 6 deviations, you add them together, okay, and then you divide, in this case, by 6. So the formula is kind of in orange over there. The average deviation, the big E thing is the capital sigma, and that means summation of. So we are going to sum the differences, all the differences, the absolute value of all the differences, and we're going to divide by the number of times we did it, which was 6. Okay? So
You said all this is going to be on Twitter, right?
this will be, yeah, this document will be pushed out on Twitter. Yeah.
Awesome.
Yep. Any questions? Okay, that's it for pre-lab and no goggles today. So.
Excellent.
I know. Don't get used to it.